All right. Let's get going. How'd the homework go overall? Hey guys, let's get going. Sorry that took me longer to get going than usual. Some makeup stuff should get checked out. I heard questions on 18 or 19. After checking those in detail, what kind of questions do we have on that? Remember, it was f of g of x or g of f of x, and then the domain. Anything you'd like to ask about? No? All right. So today, we're getting into what are called inverses. Where have you heard the word inverse before in math? Inverse operations. When do we do inverse operations? (5x equals 20). 5x equals 20. What do we do to both sides? Divide by 5, because 5 is dividing by 5 is the inverse operation of multiplication by 5, right? So when you're solving, you typically use inverse operations. Now that's different than what's called the inverse of a function. So we'll get into it today. They like to introduce it in a little bit different way, which I'm on the fence about. We'll see how you guys feel about it. You can solve equations for x to obtain an equation that gives the input for a specific output. Here's what they're asking us to do. Let's read the directions. And we're only dealing with linear functions today. We need to get really good with this process with linear functions, because tomorrow we'll have nonlinear curves, all right? Let f of x equal 2x plus 3. Solve y equals f of x for x, okay? So what they want us to do, they're saying y equals f of x. So most people feel more comfortable putting a y in here instead of f of x. And the directions say to solve for what? Solve for x, yeah. How do I solve for x? What do I do first to both sides?
Subtract 3.
Subtract 3. So we get y minus 3 equals 2x. What's my last step to get x by itself? Divide by 2, both sides. And then I'm going to swap it around. Most people like to write the solved variable on the left side. What the heck did we just do? We just solved for y, or solved for x in terms of y. You know how all the time we always say y is a function of x, y is a function of x, y is a function of x? All that means is you have a y equation, and it's a function, and it has x's in it, okay? All we've done right now is solved for a different variable. We've solved for a different variable. Now we solve for x. Now let's keep reading and see what they want us to do, all right? Then find the input, x or y. What's the input?
X.
X is always the input for us, right? Find the input, find x, when the output, y, is negative 7. So plug in negative 7 for y. So we have x equals negative 7 minus 3 divided by 2. Negative 7 minus 3. Negative 10 divided by 2. Negative 5. All right, now how could we check that? Go back to the beginning, plug in negative 5 for x and see if we get negative 7 for y. Let's see it. Ready? 2 times negative 5. Negative 10 plus 3. Negative 7. Feel pretty good about that, right? All right, they're trying to get you guys into an exercise that's going to help us here in a little bit. So I want you to try to do the same thing for letter B. All right, you got this. Ramps it up a little bit. Well, did most of you guys multiply by negative 1? Or did you divide by negative 1? Multiply by negative 1. I bet most of you divided by negative 1. Do you understand to divide that into both terms, though? So it's going to, dividing by negative 1 and multiplying by negative 1 end up in the same result. It's negative y plus 3. Right? And then how do you get rid of that cubed?
Cube rooted.
Cube root both sides. So we write x is the cube root of negative y plus 3. And then what they ask us to plug in? Y is 2. All right, we have the cube root of negative 2 plus 3. We get positive 1. What's the cube root of 1?
1.
X equals 1. Is x equals 1? Any questions on that one? Anybody get tripped up by that negative being in front of the cube, the x cubed? Nobody tried to cube root first, right? You get rid of the negative first. Perfect. All right. I think this is our last one before we get into the good stuff. All right, so we're going to write y equals negative 3/5 x minus 8. What's the first step?
Add 8.
Add 8. Y plus 8 equals negative 3/5 x. I'm going to encourage you guys, instead of dividing by fractions, to multiply by the reciprocal on both sides. It's it's just a little bit more mathematically mature to do to help you get things simplified faster. So if you multiply by the reciprocal, you're multiplying both sides by positive or negative? Negative 5/3. That negative 3/5 and the negative 5/3 will make a positive 1. So we get x equals. Now, I could be convinced either way, whether it's better to distribute that negative 5/3 or to leave it like that. Let me check the book real quick and see how do you guys do it? I'm not seeing that one. If you choose to distribute that negative 5/3, now here this is the only reason, guys, listen up, please. This is the reason why this decision is like I'm on the fence about it. If it's like a 2 out here, I think everybody should distribute that in. Okay, if it's a negative 5/3, negative 5/3 y, and then minus 40/3. Okay, it's going to be tough to evaluate. Now, what if I leave it like this right now? And again, I'm saying I don't care, okay? But if I leave it like this right now, what am I plugging in for y? They're asking me to plug in negative 1 for y, right? Let's see what that looks like. I said negative 1, right? Negative 1. Do you see how that helps you avoid some fractions? Like if I had negative 5/3 y minus 40/3, I'd have to, well, it was 1, so it's not going to change the denominator in this problem, but sometimes those fractions might be more challenging to add. Versus now, if I do order of operations, I have 7 times negative 5/3 is negative 35/3. All right. Now, this is getting us into the idea of what's called an inverse function, okay? Now, here's their little diagram. Order of operations, you'd multiply by 2, add 3 if you're going to plug in a value for x, right? Here, you're going to subtract 3, divide by 2. You can probably see those operations are inverse operations of one another. And all they've done is they've swapped. They've solved for x over there, like we did in the first couple examples. This one is the original problem. All right. These operations undo each other. Inverse operations are functions that undo each other. Now, that's not really a mathematical way to put it, but what's going to happen now is to find the inverse of a function. This is if you've been zoning out, you need to listen to this. To find the inverse of a function, you're not just solving for x. That was a little exercise to show you how to undo the order of operations to get one of the variables by itself. That was not an inverse. That was not an inverse, okay? To find the inverse of a function, you have to actually switch x and y. You have to switch the variables. All right. Now there's some notation that goes along with it. An inverse function can be denoted as, that's not an f to the negative 1 power. That's read as f inverse. F inverse. Is this in your guided notes? Is this typed out for you? Or do you have to write it in? Okay. Because an inverse function switches the input and output, the domain and range are also switched. That's not going to be very exciting for us today because we're dealing with lines. Lines, domain, and range are all real for both. When you get into curves, the domains and ranges switching, especially if you have a restricted domain, like the square root of x graph, that's going to be important for us. All right. Let's create this table of values right here. This is the original function. If I plug in -2 for x, I get 2 times -2, which is -4, plus 3 is... Everyone.
-1.
Thank you. -1. If I plug in... Ooh, wait a minute. I think we're ready to fill in our first one over on the inverse function. What did I say you have to do to make an inverse function with x and y? What do you have to do? Switch. So on the first graph, I could graph the point -2, 1. Ready? -2, -1. I might have said +1. Sorry. -2, -1. That's a point on the graph. What's a point on the inverse function? -1, -2. Why? Because x and y have switched. X and y will switch. Let's plug in on the original graph. Let's plug in -1. 2 times -1 is -2. -2 plus 3 is 1. So if -1, 1 is a point on the original, then -1 is a point on the inverse. On this one, 0, comma, plug in 0, 0, 3. On this graph, 3, 0. Now, this is a nice little visual for us. Okay. This is always going to be true. The graph of f inverse is a reflection of the graph of f. But the line of reflection is y equals x. Do you remember back in geometry last year how you guys did you did rotations, you did translations, and you did reflections, right? Reflections, it was like across, we've done it this year too. We've done reflections across the y-axis, we've done reflections across the x-axis. But in geometry, you did what was called the reflection across the line y equals x. And you even had to remember the rules, like xy becomes yx. Do you remember that? I mean, you have to dig deep to remember all the rules. What was a 90-degree counterclockwise rotation? And some of you might remember it, right? Anybody remember it? XY turns into
one of them is negative. I think
negative yx.
I think it was.
So that one, you have to the 90-degree, the 270, 180, 270. You'd have to dig deep. One you do not have to dig very deep for is the reflection across the line y equals x. Guess what changes? X and y. Do you remember xy became yx? Why was that? Well, it's because they were inverses of one another. X and y became y and x. Okay, they're inverses of one another. Once you reflect it across the line y equals x, they become inverses of one another. So here's that line of symmetry. I think we would all agree once it's on that line of symmetry, they're going to have the same value, right? And the reflections of one another across that line. Can you see it? So that's an important fact that you're going to have to carry with you for the next few years, all right? You're going to be dealing with inverses a lot more later. To find the inverses of a function algebraically, switch. I'm not sure why it's saying switch the roles. Switch x and y, and then solve for y. Switch x and y. And I would even argue with this last statement. In calculus, we're not always going to be solving for y. Once you've switched x and y, you have created an inverse function, even if you don't solve for y at that point. Why would we solve for y? It makes it a lot easier to graph it. Plug it in the calculator, graph it. Oh, there it is. But once you've switched x's and y's, it's an inverse. The domains and ranges have switched. You're dealing with inverses now. Now, this wasn't one of the examples, but I want to show you what happens on this one if I find the inverse. Here we go. Ready? What do I do with x and y to find the inverse? I'm going to show you that this is the inverse. What do I do with x and y? Say switch them. Please just make me happy.
Switch them.
Thank you. Thanks. Appreciate it. Switch them. So it is y equals 2x plus 3. Now it's x equals 2y plus 3. I have created the inverse function. Okay? But they want us to solve for y. That's just a good habit to get into. How do I solve for y? Subtract 3 from both sides. So I get x minus 3 equals 2y. And then do what to get y by itself? Divide by 2. Divide by 2. Y equals x minus 3 over 2. Now be careful. That y and that y aren't the same. This y is representing the inverse function to this one, right? So that's why we then write it with this notation, f inverse of x. F inverse. So that you're like, oh, wait, how's that y and that y? Are they the same? No. This one, we've switched those x's and y's. It's now the inverse, okay? Here we go. Find the inverse. So to find the inverse, we're going to switch x and y. Switch x and y. So it's going to be x equals 3y minus 1. Add 1 to both sides. X plus 1 equals 3y. Divide by 3. Y equals x plus 1 divided by 3. And to make sure we know that that's the inverse function, we'll write f inverse of x equals x plus 1 divided by 3. All right, let's go ahead and graph those. So let's do the original, a quick little XY chart, okay? X comma f of x. I guess we'll do -2, -1, 0, 1, and 2. And then we'll do a inverse XY chart. X comma f inverse of x. All right, let's plug into the original first. 3 times -2, -6, -1, -7. Yeah, let's keep going. Net plug in -1. 3 times -1 is -3, -1 is -4. 0, -1. 1 is 2. 2 is 5. Let's go ahead and graph those. All right, -2, -7. It's off the page a little bit. -1, -4. 0, -1. 2, 5. All right, should I start plugging in the same values into the inverse function? Could, but what do I know to do if I have already the table of values for the original? Yeah, so -2, -7 is now going to be graphed as -7, -2. Well, -7 is off the page, but let's go here, -2. -1, -4 is now -4, -1. 0, -1 is now -1, 0. 1, 2 is now 2, 1. And 2, 5 is now 5, 2. And then give it just the visual test of, does that look like the line that has been reflected across that line y equals x? So kind of, if I were to draw the line y equals x, remember, y equals x is the line where all the x's and y's are equal, right? I know it doesn't need stated, but -6, -6, -5, -5, -4, -4, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Yeah, it looks like it's been reflected across that line, doesn't it? Now, I think that confuses the picture a little bit, but give it that visual test, make sure it looks right. If it doesn't look right, you did something wrong. All right, graph the function and its inverse. Perfect. All right, you try the next one. Now, I did both tables of values. That little, what you guys called them last year? Tables of values, or did you call them XY table?
Table of values.
Thank you. Table of values. I did both of them so you could just see that the x's and y's can switch. We're dealing with two lines. I bet most people could graph this line by using the y-intercept and the slope, right? If your goal is to graph the lines, just graph them however you want. If you want to use a table of values, that's fine. If you want to graph this line by, it's a y-intercept of -2, rise, and then a slope of 1/3, rise 1, run 3, rise 1, run 1, 2, 3, rise 1, run 2, 3. That's fine too. Down 1, left 1, 2, 3. And then 3x plus 6 is pretty easy to graph. Y-intercept is 6. Slope of 3 over 1. I know this probably doesn't need stated, but if you rise 3 and run 1 to the right, and you run out of room, you could also go down 3 and go to the left 1, right? To get the slope of 3. Like I can go down, did I say down 3, left 1? There's the inverse. How do we do on those? Good. All right. Now, one thing I told you at the very beginning of class, I was on the fence about I'm not sure how I liked how they explained it. Why do you think, in case you have to do this in your homework, because this is where students are going to get confused, okay? Was letter A an inverse problem? Did they ever ask you to switch x and y? No. What did they do? Just as a exercise, they had you solve for x. Right? They just had you solve for x. Now, here's what I would have hoped they would have done with this. Okay, made the connection. Everybody watch up here. Do you see how in letter A, example 1, letter A, they had us solve for x? Isn't it set up right now to find the inverse pretty easily? What could I do to find the inverse of this function right here? Switch x and y. What's the inverse of this? Y equals x minus 3 over 2. Right? So they had us get to that point. They just never had us switch the variables. So if they ask you to do one of those in the homework, don't switch the variables. They're just getting you to see that you have to do the inverse operations to get it to that point, and that's set up to find an inverse. They just never did that. All right, homework for tonight. 7 minutes to start.